Following, find h double prime at 0 given that h x equals x times e to the x. So we have a function here h which is a product of x and e raised to x, and it wants us to determine h double prime 0. That means we need to determine second derivative of this function first, then replace this x by 0. Okay, so we need to find the derivative first, then evaluate. So let's find second derivative of this product. So here we got h is x times e raised to x. So it's a product. So when we find its derivative, we must use the product rule, which is when we have f times g, its derivative is f prime times g plus g prime times f. So that is h prime equals derivative of first factor, all that means f prime means derivative of first factor times leave second alone, plus derivative of second factor, derivative of ex is ex, times leave first alone. So this is first derivative. 1 times ex is in fact ex plus x times ex. Since we have to find second derivative and evaluate at 0, it's better to simplify. So we got two terms. Simplify means always factor the common factors. So here e to the x, we can factor e raised to x out. That leaves 1 here plus x. So 1 plus x. So we still have e raised to x times quantity 1 plus x. We still have a product. This is first derivative. Now let's find second derivative. That is derivative of this, which is a product. So we need to use product rule. Again, the same product rule. Derivative of first factor itself times leave second alone, plus derivative of second factor. Derivative of 1 is 0, plus the derivative of x is 1. So 0 plus 1, 1. So derivative of second factor is 1 times first factor. We don't have to simplify anymore because now we're gonna evaluate at 0. So h prime at 0 means replace x throughout by 0. Now h double prime at 0, e raised to 0. Okay, a number raised to 0 is 1. E is an irrational number, and a number raised to 0 is 1 times 1 plus 0, which is 1, plus 1 times is nothing. E raised to 0 is just 1. 1 times 1, 1 plus 1 equals 2. So the final answer is 2. Now second question here, find the fourth derivative of this fraction 3 over x. Okay, so the function is 3 over x. This is a fraction or a quotient. We can use the quotient rule if we like, or we can get rid of this fraction writing like this, because the x means x raised to 1. Just move up 3x raised to negative 1. Okay, we can do this. Now that's the function. We didn't do anything. I just rewrote this function in nicer way so that I can apply power rule xn. A constant survives, just constant. Xn, the derivative of x raised to n is n x n minus 1. So bring n x n minus 1. Let's do it. So first derivative is this 3, just 3 there, times xn. N means negative 1, n x n minus 1. Negative 1 minus 1, that's negative 2. Let's simplify. So 3 times negative 1 is negative 3 x to the negative 2. So we can put x to the negative 2 on the bottom to make x squared, but we are finding fourth derivative, so let's leave in this way. That's the first derivative. Let's find second derivative in the same way. a constant xn using the power rule. So negative 3 is negative 3 times xn. Derivative of xn is n x n minus 1, negative 2 minus 1, negative 3. Oh, we can multiply negative 3 times negative 2. Negatives positive, 3 times 2 6, x to the negative 3. So we need to keep working on third derivative now. Third derivative is just that, negative 3 times 6, we can multiply. Negative 3 times 6, negative 18 x, negative 3 minus 1, negative 4. Now fourth derivative, 1 2 3 4, negative 4 times negative 18, negative positive, 4 times 18, 72, x, negative 4 minus 1, negative 5. Okay, like n x n minus 1. We may leave here, but the better answer would be 72, not the 75, over x raised to 5, because negative means put on the bottom. Okay, final.